right, here we go. Okay, so since I couldn't factor, I have to use my calculator to find some zeros. And I also wanted to mention that how many real zeros do we see? Two real zeros, meaning there they really are, really. Okay, so if there's two real ones, what must we conclude? Then there must be two imaginary. How do we know that? Yeah, because it's to the power of 4 means there's 4 solutions. That means 4 complex solutions, meaning a couple of real ones, and therefore 2 imaginary ones. And imaginary ones always come in pairs. It's hot in here. It's really hot, man. I should just not do that. All right, so I'm going to take one of my zeros and use synthetic division. So 1, -1, -2, -4, -24. All right. Then we can bring down the 1, and then we multiply and get what? -2, and combine and get? Multiply and get? Combine? Multiply. Combine. Multiply.
24.
Combine.
0.
Excellent. So it has a remainder of 0. We could do a couple of things. When I look at this polynomial, I know that I started with x to the 4th, and what I just did was divide by x plus 2, which reduced to the power, now it's x cubed. Well, when I look at this polynomial, I can look at that and say, oh, I can factor that. I can do factor by grouping, okay? Would you rather we do factor by grouping, or we could do piggyback synthetic and do another 0?
Grouping is quicker.
Okay, we're going to take a vote, so raise your hand if you'd like to do grouping.
Wait, I think you have a vote over there too? 2 votes.
Quicker.
All right, that's 12. And then how many want to do synthetic division?
Ooh, that's close.
Oh, it's a tie.
Yeah. Wait, I have to
Shut up. Yeah, shut
Okay,
up.
we'll do whatever you want. Okay, I'm going to do factor by grouping just to remind you I had to do it, okay? I do believe synthetic division would have been quicker. Yeah. All right. So I have my function f of x, and we divided by what factor? X plus 2. And then what's my quotient? Plus 4x minus 1. Very good. Okay. And so I said we can do factor by grouping here. And so this is really just to remember how to do it. So factor by grouping, then I look and say, hey, what's the GCF in the first 2 terms? All right. And if I take out the x squared, what's left behind? And then if I take out the GCF of the last 2 terms. All right. Then what's left behind? Okay. And then you'll notice they both have a common factor of x minus 3. So I can pull that out in front as well. And that leaves behind x squared plus 4. Now, here we are in quasi-factored form. All right. But this is not a product of linear factors, which is our goal. Because here we have linear factor. This one is quadratic. All right. So what we're going to do is first find all the zeros. Well, that's easy to do. What's my 0? -2 and 3. Okay, and how do I find this one? It's imaginary, so you would have to do what? -4. Okay, so I can move the 4 over, and then square root both sides. Don't forget, plus or minus. So x equals plus or minus 2i. There you go. Okay, because we got a negative under the radical, and I comes out, and the square root of 4 is 2. So these are our zeros, which is kind of nice, and we have 4 of them. Once you find those zeros, then it's actually really easy to write our product of linear factors. I already know that if x equals -2, my factor is x plus 2 and x minus 3. But if I have a 0 of x equals 2i, what bubble did it come from? I want a linear factor. X minus 2i, very good. And if I know that x equals -2i, what bubble did it come from? X plus 2i. So by finding these zeros, it's very easy to convert them to bubbles, right? All we have to do is push them back over, right? This is a product of linear factors. Everything is x to the first power, and it's much easier to do that when you actually have solved for the x's. So that's our goal. Synthetic division would have been way faster, but that's just fine. So now that we know imaginary solutions always come in conjugate pairs, positive and negative, we need to take that home for the next. Example 2. Find a polynomial with real coefficients. Oh my geez, it's hot. Oh.
Come on, Mr. Davis.
Why do we turn on the heat?
Let's sign a petition.
All right. I used to do that a lot when I taught at Sabino, because Sabino had a bunch of picnic tables like in the shade, and I don't know why you guys don't have any picnic tables like in the courtyard, like right? Like place to sit. All right. We want to find a polynomial with real coefficients that has the given zeros. So here they're telling us we have x equals 1 is a 0. And they're also telling us that x equals 3 minus I is a 0. But if this one is imaginary, what can we also conclude? There is another one, and it would be 3 plus I, which means we have 3 zeros here. And what I need to do then is convert it to a polynomial that we're going to multiply together. So if I know the zero is x equals 1, what bubble did it come from? X minus 1. All right. If I know x equals 3 minus I, what bubble did it come from?
X minus 3.
Oh, getting warmer. X minus 3 is right. Plus I. Why? Because you got to move it over, right? Set it equal to 0. Oh, yeah? You see that now? Okay. Because that's all we're doing. We're just pushing it back so we get the equation x minus 1 equals 0. And that's, right, that's how we solve, all right? So in reverse, okay? So then if I know that x equals 3 plus I, what bubble did that come from? X minus 3 minus I. Very good. All right. So again, just moving those over. All right. Now we have to multiply all this together. And that can be incredibly complicated, or you can take a step back. We cannot leave it like this. This is actually kind of a good thing for calculus. So this is something I haven't done before. And what we want to do when we're at this level of math is be able to step back and a package. Oh man, what is it?
It's a fan. Can we multiply the 2 right there and then do synthetic with 1?
So yeah, and at this level, what we really want to do is we really want to look for patterns. And so I want to point out that these 2 bubbles look like patterns, right? They both have an x minus 3. You see that now? Yeah. Okay. And when I look and step back and I don't see the x minus 3, I see something plus something times something minus something. Okay? I see, when I look at that, I see the sum and difference pattern. All right? And if we think about our sum and difference pattern here in multiplying, I'm going to do first times first and get a squared. What happens to the outside and the inside products? They cancel out because it's negative AB and positive AB, and those go away. And then I'm left with last times last, which would be negative b squared. So it's really a squared minus b squared is all I have to think about. Same holds true for this. I have to ignore the first bubble. We're going to multiply these two together. First times first is going to give me x minus 3 quantity squared. Last times last gives me negative I squared. I still have my x minus 1 out in front. We'll deal with him later. And I can do some cleanup here. First of all, x minus 3 quantity squared. What do we have to do with x minus 3 quantity squared? Multiply it out. Yeah, it's x minus 3 times x minus 3, which gives me what? Minus 6x plus 9. Very good. And then, what happens with the I squared? It's a negative 1. So we have minus a negative 1, which turns to plus 1. Okay. Okay, so again, I can clean that up. We have, and again, I can do these in my head, but you probably can't yet. Hopefully you'll see the pattern. 9 plus 1 gives me 10, and now I have to multiply x minus 1 times this trinomial. Which can be a lot of work, but I love the box method. I don't know if I've showed you guys the box method.
I've never seen
Those
that.
were groans of pleasure.
I'm curious.
That's how I learned how to
Yeah, remember that? That was super fun. All right, so I love the box method. You can just do distribution if you want to, but I love the box method. We just fill in all the spaces. So x squared times x is x cubed. Negative 6x times x is negative 6x squared. 10 times x is 10x. I love how it just keeps things nice and neat and organized. X squared times negative 1 is negative x squared. Positive 6x and negative 10. Keeps things nice and organized because it's so tight.
Thanks.
And then it's actually really easy to add up all the like terms. So I have an x cubed. And I have a negative x squared and a negative 6x squared, which gives me negative 7x squared. And then I have a 6x and 10x, which is 16x's. And then last, but certainly not least, a negative 10. So really, this is just you practicing multiplying special patterns in sort of weird and different new ways. Does it seem terrible up there to you? Like it's out of focus to you? It seems awful to me. I'm sorry. Do you have any questions for me? All right, ladies and gentlemen, there you go.
Homework of the day.
You guys.